This video is about the rules of exponents. When we talk about the rules of exponents, we need to first understand what is an exponent. So an exponent is sometimes called a power, and it is like a superscript on what we call the base. And what it means is we're going to multiply that base by itself, the power, that exponent number of times. So a to the m would be a times a times a, m times. So as an example, if we have x cubed, what it means is x times x times x. This is just a shorthand way mathematicians use so that we don't have to write something like y to the 17th and write y out 17 times. There are actually 7 rules of exponents that you should know. The first one is called the product rule, and it states that if you're going to multiply the same base to different exponents, they could be the same exponent, you add the exponents. So, quick example here, if we have x cubed times x to the 5th power, we get x to the 3 plus 5, or alternately x to the 8th. For this next example, we have both x's and y's. So the first thing I'm going to do, although it's not really necessary, is write my x's together and also write my y's together. So I have the same base together. And then I'm going to add the exponents. So keeping in mind that this is an x to the first, x to the 1 plus 2 would be x cubed, and y to the 7 plus 2 would be y to the 9th. The next rule is the quotient rule. And for the quotient rule, it's very similar. When you multiply the same base, you add the exponents, but when you divide, you subtract the exponents. So we're going to do that on these 2 examples here. X to the 7th divided by x squared would be x to the 7 minus 2, the numerator power minus the denominator, or x to the 5th. You may have seen this before if we think about it a different way. If we say x times x times x times x times x times x times x, 7 x's, divided by 2 x's, we can cancel, that's another way to think about this, 2 of those with 2 of those, and we're left with only 5 x's. For this next example, again, we have both x's and y's. So we're going to handle the x's separate from the y's, and we'll use our subtraction rule. So we'll get x to the 3 minus 1 and y to the 8 minus 1 for a final answer of x squared y to the 7th. The next rule is the power rule. The power rule says if you're going to raise a power to another power, you are going to multiply the powers. Power to a power, we're going to multiply the powers. So that means x squared raised to the 3rd should be x to the 2 times 3 or x to the 6th. So again, just a quick explanation. This means x squared multiplied by itself 3 times. And then the first rule we talked about says add the exponents, and 2 plus 2 plus 2 is 6. Similarly, if we're going to raise y to the 5th to the 7th power, we're going to multiply those powers, 5 times 7, or y to the 35th. Much nicer to write it this way than having to write out 35 y's. The next rule is the zero exponent rule. This says that almost anything raised to the 0 power is 1. The only one that is not is 0 raised to the 0. That's actually undefined. So let's take a look at some of these examples. In this first example, right here we have y to the 0, but y to the 0 is 1. So this expression is just 5x squared. For our next example, we have this whole expression raised to the 0, and like we just said, this whole thing is just going to be 1. Anything raised to the 0 power, as long as it's not 0 to the 0, is 1. And for our last example, we notice 5ab cubed c to the 0 divided by 25ab. Let's first take a look at our c to the 0, which we know is 1. And then let's think about, we're kind of combining some rules here. 5 over 25. We also have a over a. And we have b cubed over b. So if we use our rules, 5 goes into 25 5 times. A to the first over a to the first would be a to the 1 minus 1, or a to the 0. B cubed over b would be b to the 3 minus 1. And so our final result, if we simplify, would be 1/5. A to the 0, of course, would be 1, and b squared. So I can write it like this, or I can write it as b squared over 5, which is a little cleaner. Just a couple more of these exponent rules. The first one is the negative exponent rule, and it says if you're going to raise a base to a negative exponent, you can make that into a fraction and move that down with a positive exponent. It also works the other way. If you have a negative exponent in the denominator, you can move that to the numerator of a fraction and make it positive. So for our first example here, we have two negative exponents. We have x to the negative 3, which could be moved to the bottom and become x cubed. And we have y to the negative 5, which could be moved to the top and made y to the 5th. And typically when we represent something using exponents, we don't want to have negative exponents. So keep that in mind. For this next one, I'm going to think about this using a couple of rules. So let's take a look at just our a's and just our b's and use first the quotient rule. So that would be a to the minus 1 minus 2 and b to the minus 2 minus 4. So we have a to the negative 3 and b to the negative 6. And if we don't want to have any negative exponents, I can move both of those to the denominator and make those exponents positive. So here we used kind of a combination of the quotient rule. In general, too, we could have just taken one of those a's and moved it to the bottom, giving us a cubed. And the two b's we could have moved to the bottom and made it b to the sixth. Just a different way to approach the problem. The last two rules say, if you're going to raise a product to a power, you're going to raise each piece of that product to that power. So a quick example would be 2x cubed would be 2 cubed x cubed. It's very, very common to forget to raise the coefficient to a power. In this case, 2 cubed is 8, so we get 8x cubed. In a similar fashion, if we're going to raise a quotient to a power, we're going to raise each piece of that quotient to that power. So again, a quick example would be something like a squared over b to the negative 1. And we're going to raise that to the third. So we're going to, raising a power to a power, we're going to get a to the 2 times 3, which is 6. And b to the negative 1 times 3, which is b to the negative 3. And then we'll use that power that we just used and move that b up. So a to the 6th, b cubed. So here's our last rule examples. We're going to raise 3x squared to the 4th power. Means I'm going to raise 3 to the 4th, and I'm going to raise x squared to the 4th. Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. And then x squared raised to the 4th, we're going to use our power to a power and get x to the 8th. I'm going to change this one just slightly and make it negative 5 y squared over x to the negative 2 cubed. Now I want to point out that I can handle this x to the negative 2. I could move that up first and then cube everything, or I could cube everything from the start, and that's what I'm going to do in this particular case. So I'm going to get negative 5 cubed y squared cubed and x to the negative 2 cubed. Notice I'm writing it all out. I don't want to try to do things in my head. So negative 5 times negative 5 is positive 25, times negative 5 is negative 125. Raising a power to a power, we multiply those powers and get y to the 6th. And then when we raise x to the negative 2 to the 3rd, I get x to the negative 6th. I can put that on the bottom. But then again, we don't want negative exponents, so we're going to move those x's up and make it a positive exponent. So this is our final answer for that one. So that's just kind of a quick tutorial on how to use these. Let's do a couple of problems that are maybe a little more complicated. So as long as I follow those 7 rules, I should be in great shape. So we'll call this example 1, or B, A, B, and then C, and see if we can't simplify. So again, on this one, I can handle that 2 and raise everything to the 2 power like we just did, or I can handle my negative exponents first. So in this case, let's do those negative exponents first. So we're going to leave the square, and I'm going to look at these two m's here. So if I move those down, the m to the first down, I'm going to get m to the 4th in my denominator. And when I look at my n's, if I move those 4 up, I'll have a total of n to the 6th. Now I'm going to raise each one to the 2nd power, and my final result is going to be n to the 12th, raising n to the 6th squared. We multiply those powers. And similarly on the bottom, m to the 8th. So it looked really bad. As long as you break it up in little steps, you should be fine. All right, let's take a look at this next example. I noticed a couple of things right away, and I hope you do too. The first is that we have this a to the 0, and anything to the 0 power is 1. So we can just cancel that right now. The other thing you may notice is that 2 over 2 is actually 1 as well. So let's just handle those two things first. We've got 3b squared over b cubed, all raised to the negative 5th. So again, I have options here. If I want to, I can move this negative 5 in to each one, or let's continue simplifying the inside here. This would be 3b, 2 minus 3, because that's the quotient rule, would be negative 1. And we're going to raise that to the negative 5th. So now I'm going to raise each piece of this. This is our rule when you have a product raised to a power. And we're going to get 3 to the negative 5th and b to the positive 5, or b to the 5th. Moving this down because it has a negative exponent would be 3 to the 5th, for a final answer of b to the 5th over 243. So again, one step at a time. Don't try to do it all at once. Okay, for our last example, let's try to handle these exponents here and also here first. And this is a multiplication symbol in here. So we still have negative x, the whole of negative x, and we're going to cube it. And then y, when we raise a power to a power, we're going to multiply those. So that's going to give us y to the negative 3. So that's our first piece. Our second piece, we're going to raise a power to a power. So negative 3 times negative 2 is positive 6. And y, keep in mind this is a 1, so y to the first raised to the negative 2 is y to the negative 2. And then let's handle, I think we're going to do this in 2 steps. In fact, let's back up just a little bit. Let's actually think of this as negative 1 times x times y to the minus 1 cubed. So let me go in here and say this is actually, it doesn't really make a difference which way we do it, but I'm going to call this negative 1 cubed and x cubed. So this here is just another way to think of this piece right here. All right, so let's take all of our negative exponents and move them down. And let's also at the same time raise negative 1 to the third. So negative 1 times negative 1 times negative 1, an odd number of times, is going to give us a negative. And let's use, again, we have options here, but let's use our first rule that says when we multiply the same base, we can add the exponents. So x cubed times x to the 6th is x to the 9th. Similarly, y to the negative 3 and y to the negative 2. If I add those, I get y to the negative 5. And then I'll get x to the 9th. If I move this down so that I have a positive exponent, I get y to the 5th, and I have a negative here. So just a quick caution here. We don't move the x to the 9th down because it's negative. The only time we move something is when it's a negative exponent. So only negative exponent expressions are going to move, not negative numbers. All right, that concludes this video. See you next time.